Okay, in lesson 3, we're going to be looking at equations, linear equations that have x in them, and then determining what type of solutions they have. That means what could x be or what will x be. And they may give us a range for what x could be. We've got to plug them in and see if they are true. So let's look at number 1. It says, is the equation a true statement when x equals -3? In other words, is -3 a solution to the equation 6x plus 5 equals 5x plus 8 plus 2x? So here's our equation that we're going to have to figure out if -3 will work when we plug it in there. So all we have to do is take this -3, and I'm just going to put it everywhere I see an x. So here we have 6 times -3 plus 5 equals 5 times -3 plus 8 plus 2 times -3. And then I'll begin to solve. Well, 6 times -3 is -18 plus, that's just 5, equals 5 times -3 is -15 plus 8 plus 2 times -3 is a -6. Now -18 plus 5 is -13, so that side's done. -15 plus 8 would be a -7, and then if you add another -6, that does end up being -13. So since the two sides, once I plugged the -3 in, since the two sides of the equation ended up being equal, then yes, -3 is a solution. So we will say -3 is a solution. Then we have to explain, because when plugged in into the equation, each side was equal. So again, all we did was just take what x is that they told us, plugged it in, figured out if it was equal or not. So moving on to number 2. Number 2 says, does x equals 21 satisfy the equation 16 minus 1/2 x equals 3/4 of x plus 1? And actually, I apologize, that should be x equals 12. Copied that down wrong. So again, all we're going to do is take that 12 and plug it in right where the x's are. So 16 minus half of 12 equals 3/4 of 12 plus 1. So I know half of 12 is 6. 3/4 of 12, well, 3 times 12 is 36. Divided by 4 is 9. And then I still have the plus 1. 16 minus 6 is 10. 9 plus 1 is 10. So we'll say 12 is a solution. And then the same explanation as what we put on number 1. Because when plugged into the equation, both sides were equal. Okay, so again, we're just taking that number they give us for x, plugging it in, and seeing if it's true. Okay, number 3 says, Chad solved the equation 24x plus 4 plus 2x equals 3 times the quantity of 10x minus 1. And is claiming that x equals 2 makes the equation true. Is he correct? So again, we'll just take that 2 and plug it right in. So 24 times 2 plus 4 plus 2 times 2 equals 3 times, and then inside there we'll have 10 times 2 minus 1. And then begin to solve. 24 times 2 is 48, plus 4, plus 2 times 2 is 4. And then I'm going to have to solve what's inside these brackets first before I can multiply it by the 3. So 10 times 2 is 20, minus the 1 is 19. Okay, 48 plus 4 is 52, plus 4 is 56. And then 19 times 3 is 57. So these are not equal, and we show that just by putting a slash through the equal sign. So we'll say 2 is not a solution to the equation because, say, both sides were not equal. And what that means, whether the sides are equal or not, what that means is if you were to graph this equation, it would make a line, but 2 would not be part of that line, is what that, seeing if they're equal or not, what that shows. Okay, moving on to number 4. It says Lisa solved the equation x plus 6 equals 8 plus 7x and claim that the solution is x equals negative 3. Is she correct? And explain. So again, we'll just plug it right in. So negative 1/3 plus 6 equals 8 plus 7 times 1/3. So negative 1/3 plus 6, that's like, say, taking 6 minus 1/3. So that would be 5 2/3 equals 8 plus. Now 7 times 1/3, that is not 7 1/3. If we multiply this out, go straight across, we get 7/3, which is equal to 2 1/3. Okay, and we'll finish out by adding these together on the right-hand side. 8 plus 2 1/3 would be 10 1/3. And you can clearly see that they are not equal. So negative 1/3 is not a solution. And it'd be the same explanation we've been using throughout here. Okay, number 5 says Angel transformed the following equation from 6x plus 4 minus x equals 2 times the quantity of x plus 1 to then 10 equals 2 times the quantity of x plus 1. He then stated that the solution to the equation is x equals 4. Is he correct? So the first thing that they're saying was, here's what he started out with. And then he changed it to this. So he's saying all of this combined right here would equal 10. And you can clearly see that it would not equal 10. You can combine your x's. The 6x minus x would be 5x. And then you'd still have the plus 4. That would be equal to 2x plus 1. So they're not even the same equation there. But let's go ahead and plug in x equals 4 into this equation right here and see if then it is true. So 5 times 4 plus 4, and then over here we have 2 times 4 plus 1. Over on the left we have 24. Over on the right we have 2 times 5, which is 10. So you can see that they are not equal, so 4 would not be a solution. Again, for the same reasons we've been using throughout. All right, number 6 says Claire was able to verify that x equals 3 was a solution to her teacher's linear equation, but the equation got erased from the board. What might the equation have been? Identify as many equations as you can with a solution of 3. So we'll just figure out one equation that ends up being 3 would fit in. So you can start with whatever you want. I challenge you to make it not just a simple equation, but throw in a mixture of multiplying and adding or subtracting or even dividing. So let's just say I make something up like 3x plus 4. Okay, I know that if I plug in 3 into that equation, let's go ahead and do that, I end up getting 9 plus 4, which is 13. So whatever I put over on the right-hand side also has to equal 13 whenever I plug it in. So let's say I choose 5. 5x, well, I know if I plug 3 in right here, that would make 15. And to get back down to 13, I would have to subtract 2. So right here, this equation, if I were to plug 3 in to each of these, each side would equal 13. So I challenge you to take a minute and I want you to come up with 2 more equations that would be equal if you were to plug 3 into where x is. So go ahead and pause the video, do that, and then once you have those 2 written down, you can pick up with number 7. Okay, now that you have that done, number 7 says, does an equation always have a solution? And can you come up with an equation that does not have a solution? Now, this is a question that's we're going to look at heavily in a few lessons in this unit, probably next week sometime. But no solution, for something to have no solution, we could look at it 2 different ways. Anything that doesn't have a solution is if you have a fraction and the denominator is 0. And the numerator could be anything, but if the denominator equals 0, it's going to be no solution. Looking at the examples that we've done so far in this lesson, anytime you have the 2 sides that don't end up being equal, that would be seen as it's not a solution. So you can come up with an equation where either the denominator was 0 or where your 2 sides of the equation would not be equal. Now, one more type of example that I want to look at before we wrap this up here. Looking at the substitution method, if I told you that we had an equation like 3x plus 5 equals 15, and we had another equation, let's say 5x minus 4 equals 16. If I were to ask you, let me fix that, is 3x plus 5 equal to 5x minus 4? That's my question. So if you look at it, we know from up here that 3x plus 5 is 15. So if I just take that 15 and substitute it right there, and then I also know from up above that 5x minus 4 equals 16. So right here, I'm going to plug that in. So are those 2 expressions equal to each other? Well, we can see right here, 1 equals 15, 1 equals 16. So those are not equal to each other. So this wraps up the lesson 3 for this unit. So go ahead and pick up a lesson 3 problem set, and that will be due tomorrow.